Hey guys, on to chapter 7. We're going to talk today about zero and negative exponents. The objective, we're going to simplify expressions that have zero or negative exponents. All right, so some new information. Let's first think back about what regular exponents tell us, what a positive exponent does. All right, it tells you how many times to multiply a number by itself. For example, 4 cubed means 4 times 4 times 4. Negative 6 in parentheses means I'm going negative 6 times negative 6. But what does a zero or negative exponent do? Any thoughts, ideas? Take a second to think about it. Before we do that, before we learn about it, just recall this is called a power. All right, we have a base, which is the bigger number, and the exponent's the smaller number up top. All right, that all together is called a power. Okay, anyway, corny, I know. All right, so I'm gonna use a table to kind of hopefully enlighten you a little bit about zero and negative exponents. Notice the top are a bunch of powers, all the base of 5. All right, 5 to the 5th, 5 to the 4th, and so on. The bottom is going to be the value. If I were to evaluate, type in the calculator, compute it, what the number is. So 5 to the 5th is 3,125, because if I do 5 times 5 times 5 times 5 times 5, that's the answer. All right, the next one is 5 to the 4th. All right, that gives me 625. But what do I do to get from 3,125 to 625? Pretty much I'm just dividing by 5. All right. The next one down is 5 cubed. That gives me 125. Again, what do I do to 625 to get to 125? I'm dividing by 5. So notice every exponent is going down by 1. The value is decreasing, but it's being divided by 5 every time. 5 squared is 25 because I divide 125 by 5. It's 1 less 5 that we're multiplying by. 5 to the first, well, 25 divided by 5 is 1, or just 5 to the first. But now it leads me with, what do you think 5 to the 0 is? Like, what did we do? We can't just ignore patterns here, right? So what do you think the answer is? Let's see. I'm going to continue dividing by 5. What is 5 divided by 5? It's 1. That's right. 5 to the 0 power is 1. I'm not making a mistake. I'm not misspeaking this one time. It's 1. All right. We're going to continue the patterns. If I decrease my exponent by 1, 0 minus 1 gives me negative 1. An exponent of negative 1. What do I get if I divide 1 by 5? I'm going to get some kind of decimal, but I want you to think of it as a fraction, just 1 over 5. What if I continue? What about 5 to the negative second power? I don't say negative squared. That's not really a thing. To the negative second power. Well, if I divide by 5 again, I get 1/25. All right. So I really want you to take a look here. Look at 5 squared and 5 to the negative second. See how they're kind of like connected here? It's the inverse. Sorry, no. Reciprocal. It's the reciprocal. Okay. Same thing with 5 to the first and 5 to the negative first. Reciprocal. We're going to go into more detail, but that explains why these things are true. That explains why 0 as an exponent for any non-zero number a, meaning any number out there, a to the 0 power is 1. All right, 3 million to the 0 power is 1. 5/16 to the 0 power is 1. X to the 0 power is 1, as long as x is not 0. Anything to the 0 power is 1. Let's get in some negative exponents now, okay? Again, I'm going to use a and n a lot in this entire chapter, okay? I'm going to call the number a, and the exponent will be n. So if I have a to the negative n power, what that means is I'm going to do the reciprocal. I'm going to take the base of a, and since it is technically in the numerator here, all right, since technically it's over 1, I need to then put it in the denominator. Anytime a negative exponent is attached to a base, what that does is it makes it the reciprocal, and the exponent now becomes positive. Okay, so let's take a look here. What if in the denominator the exponent is already negative? Well, then I do the reciprocal, and now a to the n has a positive exponent. Okay, some brief examples. 3 to the negative third, that's 1 over 3 to the positive 3. because this is going to be a really small number. It's not going to make it negative. It's just going to make it small. So if I have 1 over 3 to the negative second, what that does is that negative 2 makes this go into the numerator and now becomes 3 squared. So what would this one be? What would the example of this one be? How could we make this, turn this into a number using only positive exponents? Good. That's it. All right. It's a negative exponent in the denominator. So technically, if I wanted to, I could say it's over 1, but I don't say anything's over 1. I don't need to do that. Okay. Again, so this is a kind of important page. If you have a negative exponent, it's not simplified. All right. In order for something to be simplified, you need to have a positive exponent, meaning your final answer can't have a negative exponent in it. Doesn't matter numerator versus denominator, no negative exponents allowed. So let's simplify this. All right. What about this one? And this one? Good. Now, this is kind of a little minor detail thing. Well, major detail, but you got to be cautious. All right. You got to be cautious of negative signs. All right. Negative 2 to the 5th inside parentheses means I'm doing negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Yeah, I know that was a lot, but that's what it means, because an exponent can only attach itself to one thing. Okay. So if it attaches itself to parentheses, that means everything in the parentheses gets the exponent. All right. Like, take a look down here. See this negative 5? It's only attached to the 2 because there's no parentheses. So what this problem means is negative 2 times 2 times 2 times 2 times 2. This is saying I'm sorry, this should have been 1 over that and 1 over this. My apologies, because it's the inverse, the reciprocal of it. I keep saying inverse. I don't know why. All right. But this negative sign, there's only one negative sign because the exponent is only attached to the number in letter B, whereas the exponent is attached to the parentheses, which has the negative value inside of it. Last little piece. This is a special case. We have 3 to the 0 power, that equals 1. I explained that. And 0 to the 3rd power equals 0. 0 times 0 times 0 is 0, right? And anything to the 0 power is 1, right? Well, watch. I'm going to decrease. I'm going to decrease 3 to 2. All right. And I'm going to decrease the exponent 3 to 2 here. Still true, right? Do it the same thing here. 1 to the 0 is 1. 0 to the first is 1. Now, watch what happens. 0 to the 0 is 1. No. 0 to the 0 is 0. Wait. No. Wait, what? Can 0 to the 0 be 1, which the top row says, and 0 to the 0 be 0, which the bottom row says? Say what? Because of that, 0 to the 0 is undefined. All right, it's undefined. There's no value for it. It just doesn't exist. All right, 0, 0 can't happen. And that's